Consider the differential equation dy dx equals y squared times 2x plus 2. Let y equals f of x be the particular solution to the differential equation with an initial condition. So right away we see that we have an equation that may or may not be separable, and we have the initial condition. So this should clue you in that it's a type 6 problem. Part A. Well, I wrote type 6, yes. Part A. Find the limit and show the work that leads to your answer. Often, but not always, if you're doing a limit question on a free response AP calculus test, it is probably a L'Hopital's rule problem. So, if I stick 0 into this equation, f of 0 is -1, I get 0 on top and I get 0 on bottom. It is indeterminate. It is probably L'Hopital's rule. So, first things first, you cannot just say equals 0 equals 0. You have to show that the limit of the top is 0 and the limit of the bottom is 0. And therefore, the limit of the entire problem is indeterminate. It is indeterminate, so we are allowed to apply L'Hopital's rule. So L'Hopital's rule says that we can rewrite the limit rule as the derivative of the top over the derivative of the bottom. When we go to evaluate this, f prime of 0 takes a little bit of work, and cosine of 0 we can do. So f prime of 0, the meaning of that is, what is the slope of the function? Oops, that should be 1, sorry. F prime of 0 means the slope at x equals 0, and we do have a slope equation. That slope equation depends on a y input and an x input, and our x is 0. Well, what is our y value when x is 0? Our y value is -1. So if we stick -1 in for y, we get -1 squared, and we stick 0 in for x. This gives us the value of the limit. That's going to be 1 times 2. The limit after applying L'Hopital's rule is equal to 2. AP grading wise, you get 1 point if you showed that L'Hopital's needs to be applied, so that gets you 1 point, and then if you're able to draw the correct conclusion, that gets you the other point. 2 out of the 9 points. All right. Part B says use Euler's method, starting at x equals 0 with 2 steps to approximate f of 1/2. So Euler's method, there's lots of different approaches. The approach that we use in our class is we set up the table x, y. The slope is dy dx. The next line in the table is delta y is the slope times delta x. And the last one in the table is the new y value is the old y1 plus delta y. Then we insert our seed value of 0, -1. And if we're going to do 2 step sizes equaling and leading up to 1/2, our step size is equal to 1/4. So there's our 2 steps leading to 1/4. Inputting 0, -1 into the slope, we actually did that right there. So we know the slope is 2. And if we do slope times delta x, 2 times 1/4 is equal to 1/2. And our new y value would be -1 plus 1/2 equals -1/2. That y value carries down to this line, -1/2. Okay? You would repeat the process going across this line, and you would arrive at an answer of -11 over 32. Okay, so the 2 points on this part, it's worth 2 points. You're going to get 1 point for demonstrating Euler's method. And keep in mind there are more ways than the way shown here, but this is the way we learned in our class. The second point is for getting the answer. Now, I have not expressed the answer yet. I just have floating numbers in a table. So remember, you have to say f of 1/2 is approximately negative 11/32. Part C is finding a particular solution. So our first stage is going to be to separate the variables. So if I move the y squared to the left-hand side of the equation and the dx to the right-hand side of the equation, I have separated the variables. And that's where your first point on the AP test comes from. So right there, +1 if you separated correctly. Part 2 is to take the antiderivatives. The antiderivative of the left is -1 over y, and the antiderivative of the right is x squared plus 2x, and then we have a constant, so plus c. So if you have the antiderivatives correct, that's going to be 1 point. And if you remembered the constant of integration in this step, you get that 1 point as well. Moving forward from here, there is also deviation between the way that I teach it and other teachers teach it. I tend to solve for y first, and in this case, by solving for y first, I can then have an equation that I'm going to input my initial condition in. So whether you solve for y first or not, your next point comes from using the initial condition. Our initial condition was f of 0 equals -1. So -1 equals -1 over 0 plus c. Therefore, in the form that I have written this, the value of c is 1. So you'd get 1 point if you used your initial condition, 1 point for using the initial condition. And then the final point, of course, comes from writing the particular solution. The particular solution is -1 over x squared plus 2x plus 1. Okay.
That could also be.
This can also, if you were to factor it, I don't know why anybody would go through the extra step of factoring it, but they could.
Why would you do that?